Hello, everyone, and welcome.
Hello.
I'll turn it over to Christine to start. Good morning, Christine, and good afternoon to everyone there. I'm saying good morning from my morning here in Vermont in the United States, and we have a little snow on the ground here.
Good morning, everybody, or good afternoon, depending on where you are in your lunch arrangements. Add my welcome to Didi's. I'm in the UK, in the southern part of that. My name's Christine Meadows. I'm the chair for this session, and I combine science and business and forestry and farming in advice for landowners, and also I help look after and run a regenerative farm with livestock myself. So I'll just introduce you to Didi first of all, and I'm going to read you her biography. So Didi Pershouse is the author of The Ecology of Care: Medicine, Agriculture, Money, and the Quiet Power of Human and Microbial Communities, and also the author of Understanding Soil and Watershed Function. She teaches participatory workshops both in person and online, helping to show the nested relationships between soil health, human health, water cycles, and climate resiliency. She is the founder of the Land and Leadership Initiative and the Centre for Sustainable Medicine, and a co-founder of the Can We Rehydrate California initiative. She is an independent trainer and curriculum developer for the UN FAO Farmer Field School Programme and the Andhra Pradesh Community Managed Natural Farming Initiative in India. She was one of 5 speakers at the United Nations FAO World Soil Day in 2017. So welcome to Didi, and I'll just fill in my experience of working with Didi. So as a result of my participation in Elaine Ingham's Soil Food Web work, I saw an invitation to the soil sponge workshops that Didi sometimes runs. And I looked at that and I thought, yes, I have to learn about this. I have to get into this stuff. And I was really overwhelmed and enjoyed the style of work, the style of participation, the way in which everybody could learn in a non-judgmental way. So I followed that up with joining the Land and Leadership Initiative as a way of understanding more about how systems frameworks can be used and integrated in successful environmental projects. I'm very much interested in how to facilitate and make happen projects that really support the environment. So it's been a great experience for me, and I hope we'll get a flavour of this today as we look at some aspects of the soil sponge. So without any further ado, I'll just say that this will be recorded. This session will be recorded. So although we're doing it on a Zoom link rather than the Crowdcast, it will be recorded and a recording of the session made available. And we'll also make extensive use of the chat function to have you offer up ideas and share perspectives. So I hope you enjoy. Many thanks.
Thanks so much, Christine. And yes, I will start by inviting folks to type into the chat where you are sitting right now, and maybe something that's going on outside around you that you're noticing. And I'm seeing lots of people joining from all over the world, which is the beauty of this wonderful conference, and also what's wonderful about the courses that I get to teach both through the Land and Leadership Initiative and through the Soil Food Web School is that we do get a very international group. And I, rather than just taking that for granted, that means I like to use that to help us together build a more and more accurate image of how landscapes are working around the world or not working. But we primarily focus on what's working, because I think there's a lot to learn from that. So yes, wonderful to see all of these. I'm going to enjoy reading this chat after. In fact, I'm going to make sure that I can save it here. Let's see, I am now getting every message of the waiting room, so I don't know if it's possible to make it say admit all. But let's see. Okay, let's go ahead and bring up my PowerPoint in a second. You can see that, Christine, yes? Yes, okay, great. All right, so here we go. This is a very exciting topic to me. I'll just say a little shout out to a few of the people who've inspired me here. There are many, many people, but I think the primary one is a colleague, Walter Jena, who some of you may know. And he and I met at a conference in 2015, along with Precious Peary, who I met there at the same time, and I think Christine Jones. So a lot of my favorite people were all there. And we were all presenting, but I started talking about this demo of flour versus bread, which I'll show you in a bit, as to how soil and water interact when soil is healthy. Some of my students were presenting that, and Walter was using the term soil sponge and integrating that into a kind of a flow narrative of how landscapes work. And we instantly got to know each other and started working together after that. And so some of what you will hear has been influenced by that perspective, as well as traveling for many years with Peter Donovan when we were doing the soil carbon coalition work, monitoring land all around North America and getting to know lots and lots and lots of regenerative farmers and ranchers. So really getting to see these things in context rather than it just being theoretical.
You want to watch this or not?
Okay, so we're going to start with your context. All right, so if you've been somewhere either in the city or in a what might be a very degraded landscape during a summer without any air conditioning, I think most of us have had at least one or two experiences like this. So I'd like you to think of an actual place that you've been. And to feel it, smell it, hear the traffic. And you can type into the chat these things. What's it like to walk barefoot on the pavement during the middle of the day in the heat? And where do you go to cool off? Where would you jump to or run to if you were barefoot on the pavement? And what's it like to try to fall asleep at night? What kind of covering or blanket or sheet do you use or not use? What do you do to cool off at night? Has the temperature changed much when you wake up in the morning? You know, for me as a child, I grew up spending quite a lot of time in the city, but also in the country. And as a child in the city, I'd try licking my hand at a wet washcloth, jumping in and out of a cold tub of water, fluffing the sheets. And it really didn't change that much from night to morning. What's the cycle of the heat and humidity during the day and night? Is it kind of consistent? Maybe it cools off a bit? Or is it dramatic? And if it does rain, where does the rain go and what does it do? So if it rains on that pavement, where does the water go? If it rains on the buildings? If it rains in the park that's surrounded by pavement? What is the drainage system where you are? Are there gutters? Are there sewage drains? Does the water go in with the sewage water? Maybe there's an aqueduct, quickly get it away and get it off into the ocean. And I'm actually going to invite folks, if you know how easily, to click on the 3 little dots in the upper right-hand corner of your picture. And after your name, put where you are in the world, because as you type into the chat, this will give us a picture from all corners of the world as to how this works. So the 3 little dots in the upper right-hand corner where your name is, or where your picture is, and click rename and just add your place right after that, what country you're in. Great, thank you. All right, let's go to the next question, and I invite people to type your answers into the chat. So now think about summer in the country, in the rural area, lush, green rural area. Feel it, smell it, hear the bird songs, and type into the chat, what's it like to walk barefoot on the grass during the middle of the day? And if you get a little warm, where do you go to cool off? Perhaps you're walking in a place with shorter grass, or maybe it's a little too much sun coming. You need to cool off. Where do you go? And what's it like to fall asleep at night? Or to wake in the morning? What sort of covering or sheet or blanket do you use? I know for me, in the Adirondack Mountains of upstate New York, we would it would be pretty cool at night and even chillier in the morning. No jumping in and out of bathtubs there. And what are the cycles of heat, humidity, clouds, and rain during the day and night? And if it does rain, where does that rain go? And what does it do? Does it soak in? What work does that water make possible? So I'll give a little bit of my whole answers to these questions, besides just the falling asleep at night part. And then I'll talk through a little bit of the why, as to why I think this is kind of different. For me, the part of the summer where I was in the city, there are 2 cities that I spent a lot of summertime in. One was New York City, and the other was Cambridge, Massachusetts in the United States. And particularly in New York City, with so much pavement, walking barefoot. Well, let's just do the scope of the day was particularly in the city. You'd wake up, it'd be a little bit cooler than it was before. The sun would come up, and it would just start getting hotter and hotter and hotter and hotter. But it was already muggy and hot and smoggy, and the air was not very clean smelling. And there was a lot of smell of urine because even if rain had fallen, there was not really nowhere for that water to go. So urine and garbage were very strong smells there. And throughout the day, any water that was on the ground was just sort of evaporating and becoming more humidity and haze because it mixed with all of the traffic exhaust. And it would that haze would trap the humidity and it would feel like very sticky. And by evening time, a lot of heat had accumulated in all of the cement and all of the streets and all of the buildings. And it was, as I said, very, very hard to fall asleep. So because our bodies naturally want a cool environment to cool off in for our best sleep, and that was not possible. So yeah, lots of like fluffing of blankets and wet washcloths and things, and restless sleep because I could never really cool off. And in the morning, it was a little cooler for about an hour or two, and then the whole thing would start over again. And if that heat wave persisted, it built and built and built from day to day. Now, when I was in the Adirondack Mountains, it was quite different. Wake up quite chilly in the morning, really needing sweaters and extra blankets, etc. We'd start a little fire, and there was an old wood stove in the kitchen, and we'd huddle around that because this house had no heating at all. And the sun would come up, and we'd go sit out on the porch in the sun, eat breakfast, and start warming up. And it was a nice, clear morning. And if you walked around outside in the morning barefoot, there was dew on the grass. Your feet or socks would get wet, and that dew would start to evaporate off of the grass and make these beautiful mists that we would watch rising up and kind of temporarily covering the meadow and the mountains that were around us. And then it would start around noon to coalesce into big, big, big fluffy clouds with lots of sunlight in between. And we'd say, let's go swimming. And of course, in a family of people sleeping all in piles, all different ages around the house, by the time everybody got up and got breakfast and was ready to go swimming around 3 o'clock, suddenly it'd start to rain. And all of that water that had evaporated up came down, and suddenly it was not hot again. It was not hot at all anymore. It was nice, kind of moderate temperature. And we would go swimming, but it wasn't quite as hot as we wanted it to be. By evening, the skies were so clear from that rain that you could see incredible stars up above. And again, you'd have to put your sweater on, you'd have to get bundled up, start a fire. And by the time you went to bed, it was really quite chilly. So a very, very different cycle of heat throughout the day. Okay, so a premise that I'm putting forth here is that other species are essential workers with great intelligence and creativity, and that they do this work of that rural climate regulation, and that in the city, we don't have enough of a workforce to have the same climate that we are adapted to have. And that in fact, a lot of what we're experiencing as climate change is due to a lack of this work going on. And it's not just about CO2, though that of course is contributing, and of course is one of our points of agency, but that we have other points of agency places that we can help the system get back to that beautiful cycles of heat through the day, rather than this increasing heat that we're experiencing daily, but also annually, right? That in a sense that urban cycle is something that we're experiencing on a global scale, because a lot of our rural areas are starting to function as if they were urban areas. When we have those bare soils, it's a bit like having pavement, because we don't have all of the biology at work. So I'd like you to grab a piece of paper, or if you don't have paper, you can do this in some other way. And I'd like you to somehow physically represent what work you think the biological living workforce is doing to create that rural climate that I just described, and that each of you just brought into your mind. So in a lush green landscape where the temperature variation is happening from day to night, where water can condense into clouds. And I invite you to draw a picture of, and notice the flows. So it doesn't have to be an accurate picture in the sense of representing anything. I want you to notice the flows, or do a dance or a pantomime showing that work, or sing the work. You're all muted, so sing away, sing about the work. Move your body in some way to feel the movement of the work. And I'm going to read through and tell you sort of a more detailed story of what's going on in that workforce. And you can, as you're listening, I invite you to move in some way, whether it's drawing or moving your hands, or getting up, or singing along, so that you're embodying this and learning it not just with your mind. And as you're doing that, I'd like you to also keep in mind this question: what is your current role in that workforce? Okay, so this is what I call the biotic climate cycle. And I'm going to leave it on this slide for a while, so don't worry, I'm not forgetting to advance my slides. I'm letting you draw the pictures here, either in your mind or with your body or on paper, etc. So first of all, plants feed that workforce. They take CO2, they take water, they take a tiny bit of minerals, and they use solar energy to create themselves, and then feed all the workers above and below ground, on land and in the oceans. And then they create oxygen through that same process so that that workforce can breathe. And then life, so plants create life and feed life. And then life builds a water absorbing sponge out of rock particles. So plants and fungi and many other species take those little particles and turn them into this like living matrix. And here I do have a picture here for this one. Oop, here we go. And you can see they're taking these little mineral particles and gluing them together and stringing them together with fungal hyphae and little plant root hairs and these bacterial slimes and glues. And you'll notice that instead of it just being a pile of sand or silt or clay, suddenly there are these void spaces in here, these little holes where water can soak in. And that makes all the difference. And life also, by doing this, keeps those soils intact during weather events. So when the wind blows, when heavy water comes down, soils don't blow away if life, this workforce, has turned them into a sponge. Okay, so let's just for a moment here look at what the difference is between having a soil sponge and not having a soil sponge. So we're going to use flour here as a stand-in for soil that has not been organized into a sponge. This flour is like sand, silt, and clay, just the broken down rocks, and nothing has glued them together. Nothing has given them any structure. So we'll make a nice big fluffy rain cloud. And I invite you to do this at your next dinner party with your guests. And what happens when it rains on those sand, silt, and clay, those broken down rocks? What happens is, first of all, you see we are having flooding. We're having lots of erosion. We're having those little particles are getting into the water along with any chemicals or any manure or anything else that's on the top of the soil is all running down into the rivers. In certain landscapes, we would be having mudslide here. And there is nothing there. If you know that if you've made bread or something like that and you've done some baking, when you just pour that liquid on, if we were to lift this up, there's no water getting down into the underneath part. There's no water for the plant roots there. It's all on the top. Now, if the sun comes out, this is going to dry up and become a crust on the top, making it even harder the next time that it rains for anything to get through to the plant roots. So we've got all that rain has gone down, has gone down into the rivers and the oceans, and it's none of it's there available to the plants. Of course, also, if we went back to the beginning here, and if a big wind came along here, all of this soil would be airborne. And some of it would be, if you're in a snowy area, some of it would be landing on the snow, melting it faster, and making it so that the water that's on the mountaintops, it's supposed to be very gradually coming down into the valleys throughout the year, all comes down as a flood, and there is no water available later in the year. So we have a drought. We have flooding and drought in general here. You can see if the flooding and drought are both happening at once. Just tech people, there's a couple of people unmuted that I'm hearing the background. If it's possible to find them and mute, or if people could notice themselves. Thanks. Okay, so now what happens when we take biology, when life does something different, when it gets involved here? It takes all those little mineral particles, and like that first slide we saw, it turns them into a sponge. What is the difference between it raining on a landscape that is sponge-like or bread-like versus degraded and like flour? So let's see. I bet you can guess, but it's still really fun to watch. No matter how many times I do this, it's still fun to watch this part. So that rain is coming down to the soil and it's soaking into all of those little pore spaces. It is getting filtered as it goes through there, both through that big kind of carbon filter, and it's also getting broken down. Any toxins that are there on the surface are now getting broken down by the life underground. We've already put as much water as we have on the left, and it is just barely starting to seep out, but it's not, it's right now in a landscape. This is all happening underground. So it's getting cleaned and it's clean and clear. And in a functional, healthy sponge-like landscape, that is the groundwater that you're seeing around the edge. That's underground. And it's going to slowly, slowly seep out into springs. It's going to be accessible through wells. It's going to slowly seep out sideways into lakes and rivers and ponds. It's not all running down quickly into the oceans. So, and of course, if wind came along, this is not going to blow away. As you see, if a flood comes, it's not going to wash away. So huge, huge difference there. Okay, so let's go back to our story of what happens. And sorry, I just need to keep an eye on the time here because I know we have a shorter session than we sometimes have. So, okay, now with that sponge, there's also temperature regulation happening because that biological work created that sponge. When you have all of those air pockets and air spaces, it's like a layer of insulation. If you think of the insulation that we have when we wear a sweater or a jumper, if you think of the insulation we have when, if you would put insulation in your house, wherever there are little air pockets, it regulates the temperature. So a spongy landscape helps to regulate the climate underground for plant roots and underground life. So it's going to freeze more slowly and warm up more slowly. And you can do that by sticking a meat thermometer in a compacted, degraded soil and in a healthy soil on the same day right next to each other, and you'll notice an enormous difference in temperature. But there's another thing happening here, because there is water available underground, that water can come up through the plant roots during the process of photosynthesis and evaporate from the plant leaves, just in the same way that when we drink water, it moves through our metabolism and comes out on our skin as sweat when we need to cool off. So in plants, this is called transpiration or evapotranspiration. And as it evaporates, it goes from liquid water into water vapor. And when it's a vapor, you cannot see it. It's invisible. But that change from liquid to vapor, liquid to a gas, vapor is also called a gas, actually cools the air around the plants. It cools the plant leaves themselves, just like our skin gets cooled off by sweat, but it's also cooling the air around the plants. And the difference in air temperature above a transpiring landscape, again, versus a landscape where there's no transpiration happening, again, is enormous. So, this is a big part of how our temperature is regulated from place to place. So if you notice, when you are going through a place where there's pavement or bare soil versus a place where there are tall plants or forest, not just because of the shade, but because of the plants themselves, you'll notice these cool areas. So that's how we regulate the temperatures for above ground life. So the life is creating conditions to regulate temperatures both above ground and below ground. And that is essentially the climate, right? There is also something called the biotic pump that is moving moist air from one place to another. So because the air is cooler because of the plants growing there, because of that transpiration, And also because of the shading of the plants, etc. There are actually a number of other effects going on here that we could get into more if we have a little bit, if we end up having a little time at the end. But let's just talk with the transpiration. So because there's this transpiration happening, it creates these cool low pressure zones that form over these cooler, greener landscapes. And those low pressure zones are like a vacuum, sucking in moist air from higher pressure zones, for example, over the oceans. So it pulls the moist air and the clouds in that have formed over the oceans and draws them across continents. And that spreads out the rain. So now, this is what's really fun. You've probably heard about the microbiome that we have on our skin and in our guts. And of course, in the soil, we have microbes. We're learning that there are microbes everywhere. There are microbes on plant leaves, etc. But did you know that the sky itself has a microbiome? And this picture that we're seeing right here would not be happening without the microbiome of the sky. So all of that water vapor that evaporated from the plant leaves and evaporated from the oceans and from lakes, etc., is invisible until it has something to condense onto. And it can't come down unless there are microbes in the sky or microbes doing work somewhere. So to condense into clouds, primarily what it needs are trees and plants below, because the trees and other plants produce something called volatile organic compounds, or VOCs. Those are what we smell. If you walk through a forest or you crush a plant or you make a nice cup of herbal tea, those are volatile organic compounds that you're smelling, or essential oils will evaporate into these VOCs. And those VOCs help to condense the water vapor into these liquid droplets that are floating in the sky to form those mists and clouds. And the sun will keep re-evaporating that water, and then the biological material will keep recondensing it. So you'll see those mists that rise up and then become invisible for a while, and then they form into clouds again. In the oceans, there's plankton, right, that produces DMSP, which is almost an unpronounceable word, dimethylsulfonylpropionate. But bacteria break that down into dimethyl sulfide, which acts as the main condensation nuclei for cloud formation over the oceans. So, and in a forest system, there are bacteria that live in the stomata of plants, in the place where plants are taking in CO2 and letting out this water vapor, that rise up with transpiration and actually allow those clouds to condense enough water into heavy enough droplets to fall back down again. So, and then in the cold regions, bacteria help the clouds to form ice crystals that are heavy enough to fall back down again. So those are the three ways that we can make rain in a natural system without cloud seeding, is we can make them through the salts that are formed by bacteria over the oceans, the airborne salts, that DMS that I was talking about, or they need ice crystals, which are formed by bacteria, or they need the bacteria themselves, which tends to happen over diverse, particularly old growth forests. Without that, we have just hazes. Okay, so now you can see also, if you were underneath this cloud, you'd be in the shade. And that cloud formation that biology produces allows us to have these areas of high albedo, or reflecting the sunlight back out to space, and a nice cool cloud to sit underneath, some shade right from the sky. Of course, plant cover, whether it's low providing shade for the life underground or higher plants like trees that provide shade for us meaning the larger animals, not just humans. Life is also creating that shade through clouds, through trees, etc. That shade means that the surface isn't absorbing as much heat. And a huge part of the climate has to do with how much heat gets absorbed into the surface of the earth during the day. Because it's after the sun goes down, remember in the city, it's still warm because all of those pavements are like big rocks that have absorbed the heat and are now re-radiating it. And one of the biggest changes in our climate over time, one of the biggest changes is the change in nighttime temperatures. One of the reasons that our nighttime temperatures have gone up is because there's more heat being absorbed that gets re-radiated throughout the evening. The other reason is that without microbes, without life below ground that's populating the microbiome of the sky, all of that water vapor that's in the air cannot condense into clouds and cannot fall back down as rain. So there's a humid haze over the landscape rather than a nice clear skies at night. When we have clear skies at night and all those beautiful stars to look at, the heat that has collected on the ground can escape back out to space at night. That's why we have day and night. So life creates the nighttime climate that life needs to sleep. If you read the book Why We Sleep, you know how very, very important it is to have a cool evening, a cool night for our bodies to really deeply rest. All right, that temperature difference between night and day also helps life survive in another way, which is that when there's that temperature difference, the water vapor that is in the air, there's always water vapor in the air, to different amounts in different places. That water vapor can condense as dew on the plant leaves. You know how in the country you wake up in the morning and you go out and walk outside and your feet are wet? That's the dew condensing on the leaves. That's that water vapor that was in the air that now condenses onto the leaves. Just like if you have a cold glass of water with ice in it outside on a hot day, the water vapor that's in the air around that glass will condense onto essentially dew on your glass. Okay, so then when that dew then evaporates from the plant leaves in the morning, it primes the daily rain cycle. It gets that water cycle going that we just talked through. And with more moisture in the ground from rain and from dew, more plants can stay green for much longer of the year, especially in places that have more seasonal rainfall. And that grows a deeper soil sponge because it's the plants that are needed to feed the workforce underground that can grow that deeper sponge. Now, throughout all these processes that we've been talking about, life is regulating atmospheric gases. So the CO2 that life breathes out, right, through every time that we breathe out, we're breathing out CO2. And that's not just true for humans, that's true for pretty much all of life. There's a few exceptions there. That CO2 is supposed to come right up from the soil, from the underground life, and go right into the stomata of the leaves. And we're all, and right up from our mouths and into the stomata of the leaves of the trees above us. So life is providing the CO2 for the plants. And then the plants take that, turn it into themselves, feed it to more life, make more life. Our bodies are made of those gases turned into structures. So we are made out of air and water. And when that CO2 is circulating like that through life, through breathing, then we have just the right amount in the atmosphere. We have taken some old life underground in the form of fossils, fossil fuels, and burned them. And that is true also if we have a forest fire, that whenever we burn life, some of that CO2 goes back into the air. Fire is photosynthesis in reverse. So photosynthesis, the plant takes CO2 out of the air, takes water from the ground, and builds itself, and a few little minerals from the soil. But most of a plant's, if we have a big log or a big tree trunk, most of that, what you're seeing there, is actually from the air and from the water. And if we dry that log, dry that tree trunk or those branches, and cut them up and burn them, then what happens? The CO2 comes out. The water, any water that's left, evaporates and crackles. And the light, the sunlight, that sunlight energy that was captured in making that tree comes back out as heat and light. And it is exactly the same sunlight energy coming back out for us. Our bodies are the same. The heat that we produce and that comes, the energy that fuels our minds to even be listening right now, is sunlight energy. And of course, that fire takes oxygen to burn, right? You all know that if you're making a fire, you need oxygen going back in. So greenhouse gases, we all know about CO2, we're learning about methane, but the largest greenhouse gas is water vapor, that gas form. And the reason we have greenhouse gases, or the beauty of us having greenhouse gases, is we can live on this planet. We need that water vapor. We need that gas around our planet to keep the temperature regulated. Right now, we just have a little bit, it's just a little bit too much. So having CO2 in the atmosphere, having water vapor in the atmosphere, having methane in the atmosphere is very, very important to keep our planet from freezing or burning up. It is an insulating blanket for us. And if we can let life do its work, that CO2, that water, that methane is going to cycle through life, and life knows how to regulate those things. Now, one really hopeful thing before we stop for a moment and take a break for some questions is that that transpiration effect that I talked about, where the plants are transpiring water and cooling themselves and cooling the air around them. We've done some calculations, some colleagues in mine, Walter Jena, John Norman, who wrote many of the initial climate models for NASA, etc. He's a professor of environmental biophysics, wrote the textbooks on that. We've crunched some numbers, very basically on paper napkins, and calculated that if there were 5% more green, transpiring, photosynthesizing plants on the areas of the planet where plants can grow, just from the transpiration, just from that latent heat flux that we talked about, It would offset the global warming we've already seen. But do we have agency over all the places where plants could grow? Unlikely. So we calculated again, what would that look like just on agricultural areas? And in agricultural areas, if we had about 25% more transpiration, essentially more green growing plants, it would be enough to offset the global warming we've already experienced. And that's just one way in which those plants would be regulating the climate. They would also be helping to provide the shade from big fluffy clouds. They would also be helping to provide the movement of water and rain across a continent. They would also be building a sponge to capture the water as it fell and provide for more growth, more transpiration, more cooling. They'll also be providing that insulating layer for life underground and above ground. And many more processes that I'm not even getting into here because it's all happening at once. So here's this amazing sponge that is kind of the foundation for all of this. And that's why I've spent many years now trying to help people see that this sponge, it's not just a soil food web. It's not about organic matter. It's about these amazing spaces in here. And here you can see same soil type, same ratio of sand, silt, and clay. And when we don't have soil health principles going on, when we're not taking care of the soil, this is like that flower. 0 water has soaked in here. We've put about 4 inches of rain on top of this. Nothing has soaked in. All of it's run off. We've lost lots of soil. But as we start having more cover on the soil, less tillage and disturbance, more diversity, and more year-round growth, more perennial plants, suddenly the same soil type, same farm, all that water is soaking in. It's clean and clear. Nothing is running off. Okay, I'm going to stop sharing. Christine, do you know how much time we have left? And or there is a document that people can post questions in, a Google Doc. Maybe one of the tech folks can put that in the chat now.
Yes, if we repost it further down, we can.
That would be great. And I'm in a different time zone, so I'm just trying to figure out what we've got. I think we have a good 10 to 15 minutes here for.
I have 5 minutes on mine.
Oh, okay.
I think we're
at 5 minutes.
Quarter to the hour. Just over
okay,
5
great.
minutes.
Okay, well that's still some time to go ahead and take a few questions if there are any, or people can also, if it's more efficient, put them in the chat right now because that's all that will be happening in the chat. Okay, yes, let's put them in the chat. Thank you. Sound World, I see your hand is up. If you can put it in the chat, that's great, but otherwise you could go ahead and unmute if you wanted to. If I'm not sure if the settings will allow you to. Great question. Yes, John says, does my practice intersect with sponge cities? Yes and no. So this word sponge is being used in different ways in different parts of the world. Sponge cities often refers to the idea of, for example, putting more wetlands and more plant buffers in places, and yes, depaving, which is very important. But also it's like those coastal, the coastal plant communities that the plants themselves are taking the water up. So it's a little bit different, or it's an important adjunct, but it's not the same as the soil itself becoming a sponge. And if this was level 1, what are the higher levels of teaching style? So also, I love that question. this is what I would call information transfer, but with an experiential aspect. So I'm asking you to image in your mind, bring to mind real examples, post in the chat. So it's not just passive. I'm asking you to get up and do a dance. I'm asking you to try to integrate it while you're listening. When we are in a longer course, we do breakout rooms, we do conversations in the breakout rooms. People get to know each other. They really work on examples from their own lives. When we're in the land and leadership development community, which I'll put a slide up in a moment that shows you where you can find that. In the land and leadership development community, we have ongoing weekly meetings where there's no information transfer, there's no lecture. There are a set of questions that bring us into a very deep, usually 2.5 hour discussion that involves how do we design with whole systems in our minds? How do we get ourselves out of the mindset that we are all infused with all the time of extracting things or just stopping bad things from happening or being in that kind of emergency mode, and move into growing capability and bringing out the essence of each place in a way that that is regenerative. And maybe Christine, if there's anything else you want to add to that in terms of your experience of what's different between like this and when we're actually getting together in our land and leadership development community or in the course.
Yes, okay. The things I would add are that you can work much more deeply in small groups, which is hard to do when nobody's met each other in this space. And also, I would say it's not like there's a teacher and some people who are listening or participating or students. Everyone can contribute something.
Yes,
to the
very
environment.
important. Yeah, very important. And I do believe very strongly that it is not that there are no real experts in the sense, because we all have experienced our environment for better or for worse throughout our lifetimes, and there's almost everything we need to know can be found in the land around us, in the life around us, even houseplants right around us. There's lots to learn from, and it's just a matter of asking better and better questions over time and exploring them together. So quite different than the usual kind of top-down lecture style.
There's a question about evaporation of water. How does water turn into a vapor as it exits a plant? And then there's some other questions turning up as well.
Yeah. Water turning into a vapor as it exits a plant leaf is the same evaporate. It's how water evaporates, and heat is involved in that interaction. And the heat turns from, because the heat is being used up in that interaction, just like water evaporating from a stove or from your skin when you're sweating, that heat goes from what's called sensible heat that you can feel to latent heat that no longer is felt. And that's why sweating and evaporation, et cetera, are all cooling. There was another one here. Let's see that I saw. Oops, I'm going the wrong direction here. One sec. Oh, yes, this is an important one. For the additional 25% plant cover suggested for agricultural land, does the type of plant matter, or is it not having bare soil? So yes and no, the type of plant matters in that the more leaves that are transpiring, the more cooling there is. So having diversity of leaf structure and height and type, and so that if you can get plant community or forest growing where there are lots of different ways for the plant to be photosynthesizing, depending on where the angle of the sun is and how much cloud cover, et cetera. Different plants have different photosynthesis strategies. So that's one of the reasons why diversity is important. There are lots of other reasons why having a diverse plant community feeds a diverse community underground and above ground. But being able to capture sunlight and photosynthesize and take that CO2 and turn it into itself and life, and also being able to transpire, because transpiration and photosynthesis happen together in all plants, except for there are some desert plants that conserve their water and don't transpire much during photosynthesis. Cacti, for example. Let's see, the Soil Food Web School with Dr. Elaine Ingham, collaborating there. So the interweaving of the soil food web by her and other scientific work. So they invited me to talk to bring their students into more of a whole systems mind, not just the soil food web, but how landscapes work as a whole. And so I offer these courses through the Land and Leadership Initiative, but they invited me to collaborate so that we have two streams of students coming into courses. Some are coming in through her school and some are coming in through people who meet me through things like this. So it's, I think Jade posted earlier, the link lolly.teachable.com is how you will find links to my courses. But if you sign up for a Soil Food Web longer program, one of my courses is offered for free as part of that program. Yes, I think this question from Julia in Wales about reintroducing hedgerows into farming land or managing them differently could contribute to that increased 25% of green plant cover. A hedgerow is a beautiful example of something that has a lot of different leaf structure and height, etc. We know that, of course, it's also providing all kinds of great habitat, but hedgerows, bringing them back would, you know, if it was 25% of the land cover, that would provide a lot, but also simple things like making sure that there are cover crops in between plantings. It's a huge amount of time in the year where there's bare ground in most farming systems these days. And it could also be simply letting your lawn grow longer before you cut it. So if you cut your lawn down from, you know, from this high down to this, you've just reduced the amount of transpiration by 75%. So letting your lawn be longer for longer. That no mow May that some people are doing, you know, which also has many other benefits.
I think we're being hinted at, Didi, by
yes.
the tech folks that
All
it's
right.
time to close this one. It was 1:45, I think.
Great. Let me just, I'll just put up a slide that shows how you can get in touch afterwards. Hang on one sec. Here we go. Oh gosh. Sorry. Well,
People can find you if they just Google you.
yes, and here is a slide with just that. If you want to find other courses and our ongoing land and leadership development community, if you want to hang out with Christine and I and a lot of other fun folks, there is a free downloadable manual and webinars and other things at landandleadership.org. And then if you have just direct questions for me, I'm sometimes slow to reply. You may have to send it 2 or 3 times, but I will eventually get to it. A lot going on in life these days. But at didipershouse.com. I'm sorry, didipershouse@gmail.com. didi.pershouse@gmail.com. So thank you very, very much all for attending. Sorry, this was a short and sweet, but hopefully it gave you a little bit of a taste for what we're doing. And I hope that it whet whetted your appetite for more.
Thank you very much, Didi, and thank you to everyone for staying with it.